I really like yeah. I heard that. Hang on. I heard that. No, I think you can turn on. Holy shit.
All right. Okay, so just to kind of give you a little bit of a heads up. So you have, this is the last notes in this unit. So next class we'll review and then you'll take your test over this unit. Okay? Yes. All right, let's go ahead and get started. Okay, okay, let's get started. So up there at the top, okay, I want you to draw an example of a bobo, a bedseat, and a bottom. Okay, if you have a bobo, what is the answer for the horizontal asymptote? Okay. Bottom. So bigger on bottom means y equals 0. So that means that the edges of your graph are going to curve off to that flat line. So if you want to draw whatever, any kind of graph in the middle, it doesn't matter. But then remember, the edges are going to curve off to that. Okay, that's what a horizontal asymptote of 0 looks like. For a horizontal asymptote that's a bedseat, let me just give you an example. Let's say it was a 6x squared over a 3x squared. What would that go to? Y equals 2. Very good. So then you would go to 2. You would draw in your flat line. We're kind of using our imagination here since the graph sucks. Okay, and then where that flat line is, remember, you don't know what happens in the middle. Okay, but at the edges of the graph, it's going to flatten out towards that line. That's what a horizontal asymptote is. Okay? Now, if you have a bottom, what is the bigger on top? What does the N stand for? The N means you don't have one. Okay? None. Very good. So if you don't have an asymptote, then maybe the edges of your graph are one up, one down. Maybe they're both down. Maybe they're both up. Okay, but remember that if you do not have, or if it's a bottom, then your edges should go either up or down. Doesn't matter. Okay? So what we're going to talk about today is the last type of asymptote. So you could have a horizontal asymptote. Y'all have already learned about vertical asymptotes. The last type is called a slant asymptote. Okay, and the fancy word for that is an oblique asymptote. Okay, then I want to draw your attention to what the little asterisks here say. Okay, if it's a bottom, it doesn't have a horizontal asymptote, but it still could have a slant asymptote. Okay? And slant asymptotes happen when you have a bottom, but the top is exactly 1 degree bigger than the bottom. Okay? Exactly 1 power bigger on top. So let's take a look at number 1. Okay, we're going to skip these for a minute. Do y'all remember how to graph lines? Yes. Okay, hopefully you do. So if it's like x plus 4, you could graph that. You would go to 4. 1, 2, 3, 4. And then you'd rise over run. Now, if your x is alone, then you would hit the diagonals uphill. And I'm just going to sketch it here, but it would look like that. Yeah. Okay, for the second one, negative a half x minus 3, you'd go down 3. And then just like Lachey said, remember the number on the X is the slope. So you go down 1 over 2. Down 1 over 2. And then draw your line in. Okay, now remember the lines that you just drew are asymptotes. So here's what's going to happen if you have an oblique asymptote. Okay, your graph is going to curve off to that line at the edges. So what that means is it's going to do whatever it wants in the middle. Okay, just like usual. Okay, but then at the edges, it's going to curve off to that slanted line on both sides. So remember, asymptotes tell you what the edges of the graph are doing. If it's a horizontal asymptote, they're going to go horizontal. If it's a slant asymptote, they're going to match the slant. Okay, same thing on this one. Let's give this graph a vertical asymptote just so you have an option. Just draw a line in somewhere that it can't cross. Okay, and then my graph is going to follow those guidelines. So it would go here and then here. Okay, but remember, at the edges of the graph, you're getting closer and closer to that slant or oblique asymptote. Okay? All right, so let me show you how to calculate them. This is the last new thing you're learning in this unit. Remember that in order for it to be a slant asymptote, it has to have one bigger on top than on bottom. So take a look at number 1. It's an x squared and an x. Is it a botan? Okay, yes it is. And is the top exactly 1x bigger than the bottom?
Yes.
Because it's an x squared versus a regular x. Okay, to find it, you're going to do division, top divided by bottom. Okay, so right here. Now, if you remember how to do synthetic, sometimes that shortcut will work, but a lot of times it won't. So let's do it. 6x squared plus 14x minus 3. And we're dividing that by 2x minus 2. Okay, this is how you find the slant. So first question, what would I times 2x by to perfectly match a 6x squared?
3x.
Very good. 3x times 2x is a 6x squared.
Well, this is like...
Yeah, this is old stuff we already learned. Then 3x times negative 2 would be negative 6x, but then do you remember you switched the signs on the row? Yeah. So this would go minus plus. Remember your first 2 should always cross out, and then what's 14 plus 6? That would be 20x, carry down the minus 3. Okay, then we have to repeat one more time. I have a 2x, I need a 20x. So plus 10, very good. Okay, now the good news is that you actually don't care about the remainder. So once I have this top part, that's the answer. So if you wanted, you could do the 10 times the 2x, the 10 times the 2, do the plus, your remainder would come out to 17. But like I said, you don't need any of that bottom part. So if I were you, once you have this top part, you're done. Okay, you don't actually need to finish out to the remainder. Okay, so your slant asymptote answer would be y equals 3x plus 10. Okay, and then remember, that's not a horizontal asymptote. It's not a vertical asymptote. It's a slant asymptote. So I'm going to abbreviate that SA.
We have to ever graph back.
You will, and we'll do an example. Okay? So an SA is a slant asymptote. All right, take a look at number 2. Okay, first thing that we notice is the top is an x squared, the bottom's a regular x. That makes it a botan by exactly 1 power. So to find the slant asymptote, I'm going to do 12x squared plus 13x plus 10. And I'm going to divide it by 3x plus 1. Okay, first question. What would I need to times my 3x by to perfectly match a 12x squared? 4x. Then I'll do 4x times 3x is 12x squared, which is a perfect match, just like I want. 4x times 1 is a 4x. But then I have to switch the signs, so they're going to go minus. 12 minus 12 in the front crosses out just like it always should. Okay, what is my 13 minus 4? 9x, carry down plus 10. Then remember, this is the last step you have to do. What would I times 3x by to get 9x? 3. And then at this point, you have your answer. It's the top. So you don't have to do the remainder. Yeah, I'm just going to put blah, blah, because you don't care. Okay? So your answer is y equals 4x plus 3. Yes. It'll be on Friday. But we'll review on Wednesday. I know you're okay. Okay, and then remember that's called a slant asymptote. Okay? So you should now know how to find vertical asymptotes, horizontal asymptotes, and slant asymptotes. Okay, go ahead and turn the page. We're only graphing 2 of these just because obviously we've done a million examples in the past. All right, next example. Okay, we're only doing 2 of these, so try to lock in for me, please. Number 3. Is it a bobo, a batten, or a bedsy? It is a batten. Now, remember, bigger on top means there is no horizontal asymptote, but there could still be a slant if the top is 1 bigger than the bottom. Is the top 1 bigger than the bottom?
Yes. Yes.
Yes, then we're going to put a check for oblique. And then to find it, we're going to do long division. So it's going to be x squared plus 5x plus 4 divide by x minus 2. What would I need to times x by to perfectly match an x squared? Okay, x times x is x squared. X times minus 2 is a minus 2x, but then I have to change the signs. So my x squared minus x squared crosses out. What about my 5x plus my 2x? 7x, carry down the 4. What would I need to times x by to get a 7x? So I have an x, I want a 7x. 7, very good. Now remember, at this point, you're done. This is your slant. So I'm going to write up here at the top, y equals x plus 7. Okay, and notice it's not a horizontal asymptote. It's not a vertical asymptote. It's a slant asymptote. So graph that line on your picture. I'm going to go to positive 7 is right here. And then remember that if it's just an x, your slope is a perfect diagonal. So just hit those diagonals up. Okay, just like that. All right, now because this is an asymptote, okay, if you're not using highlighter, I want you to do a dotted line. Okay, but remember, this is a guideline for the rest of the graph to follow. Okay, that's not actually part of, like, it shouldn't be like a regular line in the graph. Okay, and then I'm going to label that oblique asymptote. So the edges of my graph should go towards that. Now, everything else you already know how to do. So let's finish up the question. How could I factor the top? AC chart is correct. ABC. I need numbers that are going to multiply to 4 and add to 5. What could I pick? 1 and 4. Very good. And then my A is a 1, so I don't have to worry about divide and slide. So my numbers are going to be x plus 1 and x plus 4. On the bottom, I have an x minus 2, and that piece is already done because I can't take anything out of that. Okay, if nothing crosses out, which of these features down here will I not have? No holes, but none. Okay, if nothing crosses out, you don't have any holes on the graph. Okay, vertical asymptotes come from x's left on the bottom. Do I have one? And it's a minus 2, so where's the vertical asymptote? Positive 2. Remember, you can't touch positive 2, so draw that line into your graph. Okay, I can't touch positive 2. That's good. Okay, my x-intercepts come from x's left on the top. Do I have any? I have 2 x's left on the top, right? I have an x plus 1 and an x plus 4. Then where is it going to cross the x-axis at? Minus 1 and minus 4. Very good. So on your graph, go ahead and draw those in. Minus 4, minus 1. Now, if you are asked on your homework to write those as ordered pairs, remember it'd be -1, 0 and -4, 0. Okay, but the y's for those are always zeros because you're on the x-axis. Okay, the last number that I need is the y-intercept, and remember I find that in the calculator. Okay, that's always going to be the 0 partner. So you would go into your y equals, type in your equation, and then just find 0's partner. So it'd be an x plus 1 times an x plus 4 over an x minus 2. Okay. The 0 partner comes out to a -2. And then I'm going to graph that. 0, -2 would be here. Okay. Once you have that, hit graph on your calculator and then just copy the shape of your graph onto your paper. Okay, so I'll show you mine if you haven't typed it in yet. Okay, the graph should have 2 parts. You're going to have a piece down here. And then you're going to have a piece up here. And then actually I'm noticing on the calculator, do you see how you can't see this second piece? So if you hit zoom out, then you'll be able to see this second piece up here. Okay, you can just look at mine if you don't want to zoom out on yours. Okay, but you're always going to have multiple pieces. And then do you see how your edges form a slant? It's because you have a slant asymptote. Okay? All right, we have one more left like that. Go ahead and turn the page. Okay, first question. Is it a bobo, a button, or a Betsy? Which one? Button. Remember that if it's a button, that means you do not have a horizontal asymptote. But you still could have a slant asymptote if the top is 1 bigger than the bottom. What is the top power? X. 3. What's the bottom power? X. 2. Is it exactly 1 bigger? Yes, then you're going to have an oblique. Okay, now for the division part of this, I know we covered this a long time ago, but you have to write in any missing powers. So when I do my division, your x squared minus 16, what is that missing? What power of x is it missing? It doesn't have a regular x. So you'd have to write in a 0x so that it all lines up. Okay? All right, then from there, we're dividing. What would I have to multiply x squared by to get an x cubed? Regular x, very good. X times x squared is x cubed. X times 0x is a 0x. X times 16 is a 16x.
Wait, why would you go to that amendment?
I did. It is a minus 16. I think I didn't say it though. Okay, then remember, you're going to switch all the signs, which means I'm going to go minus, minus, plus. Okay, x cubed minus x cubed is going to cross out. What happens to the minus 4x squared and the 0x squared? How much does that give you? Minus 4x squared.
4x squared.
Okay, and then 16 and negative 9 would be a 7x plus 36. Okay, then remember, I only have to do one more because I don't have to get all the way to the remainder. So if I have an x squared and I want a negative 4x squared, what do I need?
4.
What kind of 4? Negative 4. And then all the rest of this, I don't care about. That's my answer. So y equals x minus. Okay, go ahead and graph that on your picture, please. So you're going to go to negative 4. And then remember that if it's an x, it's a perfect uphill diagonal. So just hit a few diagonals each way. And then draw in your dotted line. Okay, or if you have a highlighter, that's fine. So the edges of your graph are going to flatten out towards that diagonal. Okay? All right, now for every other feature, you have to be able to factor. Will you take a look at the top and tell me what type of factoring am I going to have to do on top? It's all of our least favorite. Okay, grouping. Very good. So out of the first two, what can I take out?
X squared.
X squared. What's that going to leave behind?
X.
Very good. Okay, out of your second group, what can negative 9x and 36 both divide by? Negative 9. That gives me an x minus 4. Because remember, if the first in the group is negative, you have to pull the negative.
Oh. Even if the second one's positive?
Correct, because remember, you need these to match.
Oh.
So if you don't take out the negative from the front one, then the first won't match. Yes. Say that again. So it was an x3, but I took 2 of them out. So that's how come there's only a regular x left here. Okay, then remember, these guys have to match, do they? Okay, yes. So same check. Then remember, that's your first factor. And then your second factor comes from what you pulled out. So for the top of that, it's going to be an x minus 4. And then an x squared minus 9. Okay, so let me show you on your paper. You should now have this. This is the new top. Okay, x minus 4. Jacob, are we a little distracted right now?
Yeah, sorry.
That's okay. So x minus 4 and x squared minus 9. Okay, now, is there a part of that that can break down again?
Yes.
Yes, this one can break down into square roots. So it'd be x plus, what's the square root of 9?
3.
And x minus 3. Okay, but remember, you have to break it down all the way to see what's going to cross out. Okay, your original bottom was an x squared minus 16. How can we break that down? Square roots. What's the square root of 16?
4.
So it'll be plus 4 and minus 4. Okay, from there, what's going to cross out to leave a hole in the graph?
Minus 4.
The minus 4 is cross out, then the hole will be at positive 4. Okay, or 4 comma something. Remember, until we have that y value, we're not going to be able to graph it. So we'll skip that for now. Is there another x left on bottom for a VA?
Yes.
And it's a plus 4, so where's the VA going to be? Negative 4. You can draw that one right now. My graph cannot touch negative 4. Okay, x-intercepts come from x's left on top. Do I have any? Yes, I have a plus and a minus 3. So I need to cross the x-axis at -3, 0 and +3, 0. Okay, remember the y values for the x-intercepts are always 0 because you're on the x-axis. Okay, go ahead and draw those onto your picture. -3 is here, +3 is here. Okay, then for your very last point, remember it's the 0 partner. What parts of the equation should I not put into the calculator? The x minus 4 is very good. So on the top, I'll have an x plus 3 and an x minus 3. And then I'll have an x plus 4 on bottom. Okay. Then remember, we're actually looking for 2 things. We need the 0 partner, and what other partner do we need? We need the partner for the whole. So 0 goes with -9/4. And then 4 goes with 7/8. Now remember, if those come out to decimals, all that you have to do is divide it to see what that is as like if they come out as fractions, turn them into decimals. So second quit, 7/8 is the same as 0.8. And then I'm going to graph it. So 4, 0.8 would be here. And then y'all, when you graph it, make sure that looks like a hole. Mine doesn't really, but it's a hole. And then for my y-intercept, it was a -9/4. So -9 divided by 4 is the same as -2.25. So I would go to 0, -2.5 would be about right there. And then remember, your graph should follow those guidelines. So it's going to look like this. That it has to hit those points that you drew. And then you'll have another piece down here. So you should have one up here and then one down here. Okay, also, if you hit graph in the calculator, you probably will have to zoom out, but you can see both pieces. Okay. All right, we're almost done. Last page, you're not doing graphs, you're looking at a graph. So very last page here. Okay, first question. Will you look on this picture and tell me where you see a hole? This should be the easiest part of this test. Where is there a hole? Make sure you're giving me the X.
8, 7, 8.
Okay, I feel like y'all aren't counting right. What's the X of the hole?
Oh, it's 6. Sorry, I didn't line it up right. That's my fault.
Very good. So put X equals 6.
It looked like 7.
That's okay. Okay, and now if the hole is at +6, what will the parentheses say? So if the hole is at +6, what would the factor or the parentheses say? X minus 6. Top and bottom. Very good, Kai. Okay, because remember, in order for it to be a hole, it would have had to cross out, which would have meant it had to be in both parts. Okay, what X's can my graph not touch? There are 2 of them.
2, negative.
Okay, -2 and 3. Okay, where do those go in the equation? Top or bottom?
Bottom.
Vertical asymptotes go on bottom, so I'll put a +2 and a -3 on bottom. Remember, the factors are always the reverse signs. Okay, x-intercepts are where I cross the x-axis. Where do I cross the x-axis? 1,
Currently negative.
2, and -3. Very good. And if I cross at 1, 2, and -3, then my parentheses on top need to be the reverse of those. So it'll be an x -1, a -2, and a +3. Okay, last question. Does this picture have a horizontal asymptote or an oblique asymptote? Oblique. Circle it. And in order for it to be an oblique, it should be a bottom where the top is 1 bigger than the bottom. How many X's do you have on top? 4. How many do you have on bottom? Is the top 1 bigger?
Yes.
Okay, then you checked it. You're good. Okay? You get the idea? All right, one more like that. Almost done. Actually, can you do it?
Yeah.
Okay. All right.
This one here?
Yes. Yes. All right, try number 6. So look at the one we just did. Do your last one.
Yes.
You said it's Boba Bonnie, but
Boba.
and you already put the dotted line at 0?
Yes.
Okay.
But the X intercept is.
So do you have an X on the outside? Has to be an X on the outside. You don't have any left on top and you don't have it. You don't have the X on top.
So then I probably.
Then your -5, you have a whole +5. 5,1.
Wait, chat. No, actually, I don't think there is.
Okay. Oh, yeah.
Right, yeah.
Let me see your.
Is that one?
That's not 1.5. That's like 0.5. So they can be above 1. So just make it.
Yeah.
And then what was your y-intercept you said? Oh, there you go.
-5.
Yeah, and now see how you're going through both there. There you go. Good job. All right, for this one, the whole is at -3. So you would put x equals -3 and then put +3s top and bottom. Okay, you have a vertical asymptote. It's not drawn in for you, but it's at 1. So if the VA is at 1, then you should have an x -1 on bottom. Okay, gentlemen. I'm being bad boys back there today.
I solved it. I do not.
Wow, that is very good. Okay, your x-intercept. You have 2 of them, a -1 and a +2. Those go where in the equation? Top or bottom?
Oh, that one.
Top. Okay, and then for your oblique, you should see that you do have one. It's not perfectly flat, so the top should be 1 bigger than the bottom. Okay, which it is. So I'm just gonna put a little check there. All right, pull out your Chromebooks. You have about an hour to get your homework done, okay? You can do it.
This is very. Wow.